We'll get started after a couple of minutes. So we'll just wait for a few more people to join in, then we'll begin. So we'll get started in a couple of minutes. Let's wait for a few more people to join in. Yeah, do keep your pen and paper with you for today's session. I'll be like solving some problems and also asking you to solve some specific portions of those problems for me. So keep those handy with you. Right. So we have three people, I guess, so far. So let's wait for a couple of minutes. Okay, I think since four people have already joined, I should get started. So welcome all in this TS session on optimization methods for civil engineering. So as you like, some of you have already probably attended the last week's session. As you already know that I'll be solving some problems which are related to your assignment questions of your week two content of this course. So for this week, I'll be like solving some problems related to linear programming. And to give an introduction of myself, I have already introduced in the last session as well. So I'm Rita Pratanath. I'm a second year PhD student from ISC. I'm one of the TAs of this course. So if you have any doubts, you can like feel free to interrupt in between the class and you can ask those doubts. And also, if you have like some specific doubts related to assignments or anything else, you can also ask them in the last 10 minutes of this session. So I'll be like teaching for 50 minutes and last 10 minutes will be reserved for that. And also for today's session, please keep your pen and paper with you. Like I'll be solving some of the problems, but I'll be like asking for you to like solve some specific part of those problems. So yeah, do keep those handy. So let's get started. So the content of this week is the first one is so this is a linear program. So solving by graphical method. Yeah, hope my screen is visible. If not, feel free to unmute and tell me. Probably it is lagging a bit, but I guess it should be fine. I'll dictate. So next one is solving by simplex W. So this is an analytical method. And the third one that you have learned is solving by Excel solver. So yeah, let's see if we can cover those three in this class, or maybe some of the examples of one or two. So first one is solving this problem by graphical method, for which, so let me just write it down, solving by graphical method. For this, you would need to know how to draw the feasible regions, and then probably where is my writing visible, or I think I got disconnected. Okay, now it's connected, I guess. So there is some issue of internet, I guess, here. So that's a bit of a problem today. Uh, just a minute. Yeah. So where these uh, uh, let me write, so deleted it, feasible regions, where are the corner points, and also where will the optimal solution occur. So let's see if we can answer this. So let us take an example. So this is example one. So we need to, by graphical method, maximize z equals to 3x plus 5y, such that 3x plus 2y less than equals to 18, x less than equals to 4, y less than equals to 6, and your x and y variables are greater than equals to 0. So how would you solve this kind of a problem? So let's see how we can solve this. So as always, I would like to have this class interactive. So I'll be asking questions while I solve this problem. So let's draw it in a different color, probably. Yeah, so let me first draw the equations of two straight lines. Say I name this, sorry, we have one straight line. So let's name it this. So 3x plus 2y equals to 18. So it will go through 6, 0 and 0, 9. So this is the equation of the straight line. So now can anyone tell me where will the feasible region be for the straight line to satisfy that less than equals to inequality, whether it will be towards the origin or outward from that origin? Yeah, Manohar has raised his hand. Anyone else? Uh, you can raise hand if you know the answer. I'll probably ask one of you. Okay, so what you say is away from the origin. That means in this direction. Okay, so how do you calculate that? Uh, like, uh, by what logic have you answered this? Can you just tell us? No, I am just drawing this constraint right now, the first constraint. It's not like a maximization or anything. It's just 3x plus 2y less than equals to 18. It's what I'm drawing at the moment. Yes, yes, that's correct. And Manohar, you have raised your hand. What is your answer to this? Okay, so that's fine. I think you guys already know this. So what you have to do is that you need to put 0 and 0 here. So just put the origin value here. You will get it as 0. And 0 is indeed less than equals to 18. So that means it will be towards the origin. So you can mark it like this. And later I'll mark the rest of the portions. This point is your 6 comma 0. This point is your 0 comma 9. And now you have to draw two more constraints. One is x less than equals to 4. So for that, what you can do, you can draw a straight line parallel to the y-axis. And for this, can you tell me where will the feasible region be? In which side? Anyone? I think it's too simple. That's why you're not answering. Yeah, yeah, that is. Yes, yes. So that is also true. So also for y less than equals to 6, you will have a straight line parallel to this x-axis. So probably it will have somewhere here. And then everything will be like this will be in this direction, this will be in this direction. Then you have x equals to x greater than equals to 0 and y greater than equals to 0, something like this. So ultimately, the feasible region that you get will be marked by this blue portion. So this portion will be your feasible region. And now what you have is that you have to get the points like corner points of this feasible region. So this one is indeed 0, 0. This one is your x equals less than equals to 4 line. So it's 4, 0. This is your 0, 6. But you still need to know where this 2 points occur, like this intersecting points of these two straight lines. So let's try to find that out. One of those is 3x plus 2y less equals to 18 for the straight line, and then you have this another straight line which is x equals to 4. So that will give you y equals to 3. So this point is 4 comma 3. And then for this one, that straight line is 3x plus 2y equals to 18. And you have your y equals to 6. So that means your x equals to 2. So this point is 2 comma 6. So now you have to maximize this function, which is 3x plus 5y. So now can anyone tell me where this maximum should occur out of these five corner points that you have in your feasible region? Yeah, Diksha has raised her hand. Yeah, yeah, that's definitely one of the way of doing this. So what you have said is correct. So for that, when you put like this 0040 and 06, you will see that automatically those kind of doesn't qualify to be which can be a maximum point. But if you want to like solve this graphically, what you can do is that you know the slope of the straight line. So it's like 3x plus 5y equals to z. So you can write this in the form of y equals to mx plus c. So suppose 5y equals to z minus 3x. So your y is minus 3 by 5x plus z by 5. And your z can be anything. So it will be like a parallel straight lines depending on the value of z and with a slope of minus 3 by 5. So what you can do, you can draw those parallel straight lines and the straight line which kind of having a maximum intercept with one of the axes, like y, if you just picking the y-axis and checking it, then that will be the indeed the corner point where the maximum solution occurs. So for this straight line, I think something like this probably will happen. Let me draw it in a different color. Yeah, probably in black itself. So probably you will get some straight parallel straight lines like this, and probably this 2 6 point becomes the maximum of all. So let's check it analytically as well. So the main concern is this 2 points, 4 comma 3 and 2 comma 6. So for 4 comma 3, you have your objective. Uh, so my objective becomes 12 plus 15, 27. And for this is for 4 comma 3. And for 2 comma 6, it becomes 36. This is for 2 comma 6. And for all others, it will be less than 36 as well. So 2 comma 6 is indeed the point where this maximum occurs. So 2 comma 6 is the solution here, is the optimal solution. And z equals to 36. So this is the solution to this problem. So you can solve this kind of problems using these graphical methods, and probably you might be asked to like solve such problems in your assignments as well. Like probably the first step would be to draw the feasible region and mark the feasible region. So probably you will be given a picture where the feasible region is given. You have to just derive the equations of the straight lines and get the proper inequalities, and finally you can get to the constraints of that problem. So it's like a reverse problem of what I have discussed right now. So yeah, do keep an eye on those kind of problems. So I think if you have understood this part of this problem, you'll be able to solve those as well. So that's not a problem. So does anyone have any doubt related to this, what I have solved already? I think my writing is lagging a bit, but I hope the idea was clear. Yeah, so this is kind of fitting the objective function. So these are straight lines with slope, say minus 3 by 5. So so your z is 3x plus 5y. And from this you have found the slope and then you have drawn this parallel lines. And all these lines intersect x-axis at some point, say 0, comma a. So when you put 0, comma a in this z value, so that will become z equals to 3 into 0 plus 5 into a, that's 5a. So for if 5a will be maximized when a is maximized as well. So that means whenever for like whichever straight line you are getting the maximum intercept in the y-axis, for that corner point, your solution will be optimal. So that's the idea behind it. So I hope you know how to draw straight lines with certain slopes. You need not know the intercept, but you can draw like, unless you know the actual intercept, you won't be like drawing one particular straight line. Otherwise, it will be parallel lines. Yeah. So it's the idea comes from there itself. Yeah. So anyway, otherwise, if you're like having trouble understanding this, you can always like check for the values for which this maximum occurs and like give the answer like that as well. That's not a problem. And it is not like it will always be the rightmost corner point or something like that. It depends on the slope of the line that you are fitting. So be careful while answering these questions and see actually which corner point gives this maximum uh, in this kind of problems. Okay, any more questions related to this? Otherwise, I'll move to the next part of this problem. Uh, okay, so let me move on to the next topic. So this is the second problem, which is solution. Is my screen frozen? Or let's see. No, it's frozen, I guess. Okay. So, again, some issue with internet. Okay, let me stop sharing and reshare. Otherwise, there is some issue, I guess. Okay, I think there is some issue with this internet using my tab. Just a minute, I'll just connect through my phone. Uh, Otherwise, it's, I think there's some issue here. Yeah, so I'll reshare probably. Yeah, just a minute. Sorry about the delay. So, yeah, the connection is very weak here, actually. I hope for the first problem itself you could see my screen. So now I think I have reshared my screen and it should come up. Mm, is it feasible yet? I guess no. Okay, again some issue. Okay, I think there is some problem. It shows me in the meeting, but again, I'm getting disconnected for some reason. Yeah, so finally it's coming up. Mm, can you see it or still like a problem? Okay, okay, finally it has come up, I guess. Okay, so I think, yeah, now I think you can see it. But the internet is very poor here today for some reason. So now let's solve one problem using simplex method. So let's try to maximize 40x1 plus 30x2 subjected to x1 plus x2 less than equals to 12, 2x1 plus x2 less than equals to 16, x1 greater than equals to 0, x2 greater than equals to 0. So yeah, so let's solve this problem. So can anyone tell me what's the first step of solving such problems? So whenever you have this kind of inequalities. Yeah, yeah, that's correct. So I'll add, say, first one. Yes, yes, exactly. So we have to add slacks here. So I'll add S1, which is 12, and 2x1 plus x2 plus S2 equals to 16. And for the other, you don't need to do anything, but you have to again convert your objective. So for that, what you have to do, you have to change it into a minimization problem. So can you tell me how to change it into a minimization problem? Yeah, that's correct. So it's minus 40x1 minus 30x2. So now what you can do for the third equation also, for the problem that will be optimizing the function. So for that, you also can add something like this. So now what you have to do, I'll just write it down, your basic variables. So this is your iteration one, and then you have your variables x1, x2, s1, s2. Then you have your f, then you have to compute bi, then you can compute bi by a. So can anyone tell me for iteration one, what will be the basic variables in this problem? Yeah, that's correct. So anyone has any doubt why it's S1 and S2 here? Okay, seems like you have known through your class, so that's fine. Now, just tell me what to fill here. In the first row, which contains S1, tell me what should go here in each of these columns in this first row. So anyone can unmute and tell me. Okay, that's correct. Then 1, 1 minus 30. Okay, that's fine. Okay, okay. So seems like you have known this. Okay. No, why is it 12? This is coefficient of f. So can you tell me now? No, this f column, what will it have? Can anyone tell me? Hmm, I think it was there in the slides. I hope you have gone through the class already. Anyone? Okay, so notice that this equation you can write it down as x1 plus x2 plus s1 plus 0 multiplied by s2 plus 0 multiplied by f equals to 12. So this one also you can write it down as something like this: 0 times s1 s2 plus 0 times f equals to 16. And for this one also, minus 40x1 minus 30x2 plus 0 s1 plus 0 s2 minus f equals to 0. So now you have seen that every equation contains f, and now can you tell me which will be the column values corresponding to f? Yeah, that's correct. So whenever you have doubt, just write it down in this form. So next, for bi, what will be the values here in this column? Why is it minus 8? What do you, so I think you guys have a lot of confusion regarding this. So so what is BI? What do you mean by BI here? Can anybody tell me? Uh, like you have seen the standard form, right? The equations that you have to the constraints you have to bring it in the standard form. Someone has already mentioned standard form. So what's A coefficients A, what is X variables, and what is B in those standard form equation? Anyone? So do you know, suppose I have to write it down, I guess. So this, have you seen some equations like this in the slides that Sir presented, like in his lectures? Yeah, so what's B here? Means in general, what do you mean by B? Uh, so it's Constant means it's the right hand side of that equation. Okay. So if for all the constraints, you have to look at the right hand side of it, and that is your BI values. So that's the idea behind it. So it's just compare it with the standard form. Otherwise, I think you guys having a lot of confusion here. So here it would, yeah, that's zero. So I have written it down now. So now, can anyone tell me which one will be the entering variable here and which one will be the leaving variable from this problem? Like how? Yeah. So why is that? Can you give me the reason? Yeah, that's correct. So what's the next step that I have to do to check for which variables like enters the basis? Sorry, which one leaves the basis? Yeah. So what's BI and what's AIJ? Can you tell me now? Yeah, that's correct. So this is 12. Yeah. For the next one, yeah, that's correct. It's 8. And for the final one, that's you don't have anything. Yeah, that's it. So that's fine. So now from this, which will be the leaving variable from the basis. Yeah, I hope you have gone through the theory part of this course lectures because everything was explained so nicely in there, the concepts and all. That why you have to choose a certain things, which one will be the entering variables, which one will be the leaving variables, something like that. So is that yeah, so try like you should not forget these things because it's like once you understand the concept fully, you should not forget it. So anyone remembers like which one should leave the basis or what will be the next step in this case? X1 enters, but which one leaves out of S1 and S2? Why? Okay, was it the maximum that you had to choose or the minimum? Okay, so that's a lot of confusion I see here. So, so actually, yeah, you should not like forget these things. It's like there is a reason why this minimum ratio has to be chosen because sir has like shown with an example where he like tried to find out what is the maximum value that one of the variables that can take like without making the problem infeasible or something like that. So from that logic you can see that it should be always the minimum ratio corresponding to that variable that should leave the basis. So here this goes out. Okay, this S2 will go out of the basis. So my next step would be S1. So what should I write here now? Yeah, what should be here? The another basic variable that I have to write below S1. Okay, okay. Okay, so actually, it would be good like if you go through the lectures once before like joining the sessions from next week. Otherwise, it's fine, but I don't think you'll be able to understand. You can always go back and also watch these videos, but don't do that. Actually, try to understand it in the class itself. So I'll just solve it. Go ahead and solve it in this class. So x1 will be entering here because x1 was the entering variable from corresponding to this column. So here you have to write x1, and you know that this you have to make it as a pivot element. So I hope you have understood, like you have studied those concepts in the class. Otherwise, like uh, it will be difficult. So what you have to do, you have to change this value of 2 to 1, and for all the other columns in this, sorry, all the other rows in this column, you have to make those values as 0. So what for this one, you can make it from 2 to 1 by dividing this entire row by 2. So let's do that. It's 2 by 2 equals to 1. This one is 1 by 2. This is 0. This is half. This is 0. This is again 16 by 2, which is 8. And this you have to make it as 0. So what you can do, you can just subtract this 1, this entire row, with this modified row that you already have. So it's like 1 minus 1. This is 1 minus half. This one will be 1 minus 0. This one will be 0 minus half. This one f will be 0 minus 0. And this one will be 12 minus 8. So this one is 0. This one is half. This one is 1. This one is minus half. This is 0. And this is 4. And for this f variable, what you can do is that again, you have here minus 40, and you have to make it as 0. So what you can do, you multiply this row that you already have by 20, and you can just add it up. So for that, what you have, you will get 0 here. You will get minus 30 plus of 20, so minus 10. I hope you understand the steps. I'll write it down as well. So this is okay. This will be 20. This is minus 1. And this one will be something like 320. So what you have done is that for this row, you have done R2, if I'm naming it as R2 prime. So R2 prime is R2 divided by 2. So this one is the previous one. For R1, so R1 prime is like R1 minus of R2 prime. Yeah, yeah. So last row will be your R3 prime is R3 minus 20 times R2. Okay, sorry, it's plus 20 times R2. So if you see, this is minus 40, this is R3, and this is 2. So if you multiply 2 by 20, so that will be plus 40. So if you add those two up, it will be 0. So ultimately you have to make it at 0. So by that, I have like calculated. So it's like take this row, whatever you have, multiply the previous row by 20, and then add those two up. So it's like minus 30 you have here for the next one, and you just multiply 1 by 20, so that's minus 30 plus 20, so that's minus 10 here. Here it's 0 plus 0 multiplied by 20, so that's 0. Here it's 0 plus 1 multiplied by 20, so it's 20. And here it's minus 1 plus 0 times 20, so this is minus 1. And here it's 0 plus 16 times 20, which is 320. Okay, so this is clear. So now which one will be the variable that enters the basis? There is only one, right? It's like minus 10 you have. Only one of these coefficients is negative right now. So this one has to enter. So since I am running out of time, so I'll just go ahead and solve this. So in the next step also, what you have to do, you have to write it down like this. And then x1, x2, s1, s2, f, bi, bi by ai. Okay. So here also you have to calculate this. So for this one, it's 4 divided by half. So this is 8. And for this, it's 8 divided by half, which is 16. So you have to replace S1 by X2. So X2 will go here, X1 will remain here. And now what you have to do, you have to multiply the first column. So it's like R1 double prime will be your equals to R1 prime times 2. So multiply it, it will be 0, 1, 2. This will be minus 1, 0, 8. And for the next one, what you have to do, you can just subtract R2 double prime as your R2 prime minus R1 prime. So what you will get is 1, 0, minus 1, 1, uh, 0, this will be probably 4, something like this. And for this one, you have to make this portion as 0. So you can multiply again this uh, first row by 20 and add it up. So let's do that. Yeah, something like this. So this one will be 0, this one will be 0. Again, this will be 20, this will be 10, this will be minus 1, and again, I think this will be something like 400 or something. So this will be your final uh, tableau. So here, none of the coefficients that appear here comes out to be as negative. So what you'll have is that your final from your final row you can get minus f uh, equals to 400. So your f is minus 400, but you had changed it into a minimization problem. So for maximization problem, what we will have is that 40x1 plus 30x2. So your x1, so from this first equation, you can get x2 equals 8. From the second one, you can get x1 equals to 4, and your final objective function value will be z equals to uh, 8 times what will be 30. So I think it's 400. So that matches with this one as well. So this will be your final solution, but you need to know the steps of this simplex tableau, otherwise you won't be able to complete this problem. Yeah, so once you get this this final tableau, from that you can notice that these coefficients are not negative, so these are positive, so you cannot do anything better than this. So try to see this first equations, like this first row, you can think of it as an equation like x2 plus 2s1 plus sorry, this coefficient is minus 1, so it's minus s2 plus 0 times f. This is the right hand side equals to 8. But you already know that s1 and s2 are not in the basis, so these are non-basic variables, so these are zeros. So what you are left with is x2 equals to 8. Okay, and for the second row, you can similarly write it down as x1 uh, plus 0x2 minus s1 plus s2 plus 0f2 equals to 4. And again, you know that these are not in the basis. So this becomes 0, this becomes 0, and you are left with x1 equals to 4. Okay, so that's clear, I guess now. Okay, yeah. So this is fine. So think I wanted to cover one more topic, but hopefully you have already seen that Excel, how to solve it. So solving by Excel. Does anyone have any doubt related to that? You can directly ask me. Otherwise, probably I'll just quickly show you if time permits. Does anyone have any doubt how to solve this in Excel, or I'll just quickly show it in 2-3 minutes? Okay, then I'll show it. I think again my screen might lag, but that's fine. So, okay, I'll quickly show the same problem I'll solve in Excel that I have just now I have solved. So let me do that. Just a minute. Open Excel. Related to assignment, does anyone have any question? You can ask me right now. Like, have you gone through it or have you found anything difficult or anything? Okay, so you can go ahead and ask. Meanwhile, I'll try to open Excel. Okay, go ahead and ask. Hmm. Yeah, yeah, yes. Yeah, so for that question, I'll suggest is that so this missing values, you can directly like try to like conventionally solve those problems by simplex tableau, the steps that you would probably take. Just go ahead with that, but mainly I'll just say follow. Uh, no, it's not. So if you notice that this BI column. Uh, Suppose I had written it here as A and here is B, and I have given you this is the final tableau. Tell me what is the value of A and B. In that case, your A and B would have been 4 and 400. Okay, so it's like that. So it's not the PI by, it's just you have done some algebra, right? You like assume something to be X and later solve for that X. So it's something like that. It's A and B, it's not given to you. You solve the entire problem and just put that those values there. That's all. It's nothing else. Yeah. So for those problems, I don't know whether the problem is entirely correct or not. I'll have as having some problem, but I think what you can do, you can directly solve those problems in Excel first, and from that you will get a solution. You can put those solution in the final tableau that they have given. And from that, you already know the coefficients here and just put those x1, x2, x3 values and those slack values. Slack values probably will be zero anyway. And you will get the right hand side of those equations. So by that, you can solve it as well. So not a problem. Yes, yes. So I don't know what happens in the exam and all, but for assignments, you are like allowed to use Excel and everything. So simplex probably will take some time for you to solve this problem. uh, you can directly put those values in Excel and solve it and see what the solution looks like. And for some of the simplex tableau related questions, I think they will just ask you what will be the value after first iteration or something, what will be the value of this part in this after two iterations or something like that. So for that, you have to follow the conventional steps. So yeah, be careful with what is asked in the question. So yeah. So I don't know whether I have time or not. Maybe just quickly see if I can show you. Otherwise, I'll wrap it up. Okay. So can you tell me whether my screen is visible, the Excel sheet? Anyone? Okay. So it's visible. Great. So the problem just now I had solved at 40x1 plus 30x2. So variables, you can write it as x1, x2 here. You can initialize it to be 0. then you have your objective function. So here, what you can do, you can here write it down in terms of this variable. So it's like 40 times x1, this column, plus or this cell. Should I probably, yeah. So this cell, so 30 multiplied by this cell. So this is your objective. Next is your constraints. Okay, so you have to add your constraints. So one of the constraint was x1 plus x2. So this is x1 plus x2. So sorry about it. I think it should be okay. I think I've done it wrongly. I make mistakes sometimes. Yeah. So this will be less than equals to 12. So let's name it as G1. Then G2 will be twice of x1 plus x2 less than equals. It's visible. It was lagging or something. Okay. So what I have done is that first I've created one column of variables and another with values. I set this values to 0 and with this constraint. Constraints, you have to write it in terms of these variables. Same with objective. You need to write it down in terms of these variables, and you have to put the right hand side as well. So these are important things. Then you go to data and you'll just go to the solver, and then you have to give the objective function cell. So your objective function cell is this one, and you are solving a maximization problem. So you'll keep it this way, and you have to select your variable cells. So I have selected it. Next, you have to add constraint. So you'll just click on add. Uh, okay. So now what you have to do, this is your cell reference. This is your less than equals to, and your right hand side must come here. You add it, and the next. Oh, oh, okay. So I think there's some issue today. It still stopped. Okay, so probably, yeah, so I'm having this trouble today. So I think you have already seen this in the lecture as well, or probably the other TA can show it to you. Uh, but yeah, if it's not visible, then it's a problem. So it's like the same trick that you have to do, like one by one, you have to add those constraints, and you just tell your solver to solve by simplex method, it will give you the solution. So that's all. So yeah, anyway, I think I'm having a lot of trouble with internet and running out of time as well. So I have to probably stop in 2, 3 minutes anyway. So yeah, so probably anyone has any other questions? So there will be like questions related to linear programming formulations that I probably wanted to discuss 1 or 2 examples, but anyway, there are, because of this issues, I could not discuss those, but that's fine. I think you can do it on your own as well. I think the assignment problems are simple, and yeah, hopefully, like the formulations, you can do it on your own. And this linear program and all, probably it will seem a bit technical with your like simplex tableau and everything. But when you try to like formulate a real life problem, you will understand like what constraints is required for which reasons or something like that. So yeah, that question 7 had some issues, I think. I think another question had have some issues, probably some question 13 or something, some constraints are probably not given. So I've already mentioned it to the TS, so probably if they think that's strong, if they can correct it, or probably that those questions will not be evaluated or something. So anything else you have? Anyone else? Okay, so yeah, so there will be another session from 4 to 5. So do join that session. Other TA will take that session. So if you don't have any questions, you may leave the meeting. Thanks.